Good afternoon, everyone, and thanks for joining our webinar today. We're going to wait just a minute or so to get started to give everybody that hasn't arrived yet the chance to join us. Okay, let's get started. Hello, everyone, and welcome. My name is Julie Tremblay, and I am the Marketing and Communications Coordinator at Testo North America. We have a great session for you today on understanding and operating the Testo 300 Combustion Analyzer. And to kick things off, let's go through a few logistical matters. Our session today will run about an hour, and we'll have all attendees muted, but we encourage you to submit questions in the questions panel to be answered at the end. We are recording the session today, and we will send the recorded version of the webinar after the session ends via email. And now I'll go through a brief introduction to Testo, as well as our products and services. So for over 60 years, Testo has stood for innovative measuring solutions. Testo helps over 650,000 customers worldwide save time and resources, protect the environment, ensure quality, meet regulatory expectations, and increase the value of their goods and services. Testo is a major supplier of monitoring instruments for markets as diverse as chemical, food service and production, pharmaceutical and biotechnology, as well as commercial and residential HVAC suppliers. And our speaker today is John Feigen. John is the Southeast Regional Sales Manager for Testo North America. He has over 20 years of work experience with Testo and another 18 years with other HVAC instrument manufacturers. With over 38 years of experience in HVAC instrumentation and as the Southeast Regional Sales Manager for Testo, John also trains and educates end users on HVAC products and applications in the markets of HVAC, industrial, weatherization, safety, and gas utility. John is a certified NATE instructor and conducts technical NATE training courses for Testo on primarily 2 NATE certified classes: superheat subcooling and saturation for AC contractors, and the importance of combustion testing for heating contractors. John is a graduate of Penn State University with a combined major in marketing and environmental science. And so with that, I am going to turn things over to John to dive in.
Well, thank you, Julie, and thanks everyone for joining this presentation. This is a presentation on 300, the new Combustion Analyzer 300, and we're going to spend some time in the beginning just going over how to use the 300, taking some correct measurements, going over some of the unique attributes of the 300. Then we're going to go into virtual hands-on, where I'm going to change out of the slide presentation into what we call a power mirror. So I have a 300 on my desk here, and we're going to spend some time going through the operation of the instrument and going through the different menu structures. Then we'll go over just a little bit about the cost of ownership of a 300, the servicing, taking care of your investment, and also spending some time on, if you don't have an analyzer, what are the things you need to know to get the analyzer that meets your testing requirements. I want to thank everybody for attending this, and like Julie indicated, this should take about 45 minutes or so, and then we'll jump into some questions. Julie did a very nice job in introducing Testo as a corporation. I just want to spend a little bit of time just talking a little bit about Testo's heating and air conditioning products. Our HVAC line is the largest line at Testo here in the United States, and we put a lot of dedication into new products, and the 300 was certainly is a product that shows that, I believe. One of the things I want to bring to your attention is the last bullet there is ISO 17025, and really what that means is that our Testo, New Jersey headquarters, where we do the service work on our combustion analyzers and all our instruments for calibration and service. We are NIST and ISO certified. It's an international certification that requires um, audits, independent audits, and the audits pertain to procedures on how we calibrate and service instruments, as well as all the test fixtures that we use, and they all have to comply to a certain standard. And what really why I'm bringing this up is because combustion analyzers, it's all about the accuracy of the sensors, the oxygen sensor, the carbon monoxide sensor, other sensors that we use, and you can rest assured that your instruments are calibrated at Testo before they leave the factory under certain quality standards that maintain the accuracy of these instruments. Why are we using combustion analyzers today? Well, there's few reasons there that shows you why we use combustion analyzers, boiler tune-ups, and certainly combustion safety, maintenance, environmental gas measurements. Really, what we're doing with a combustion analyzer is we're looking at using a combustion analyzer for combustion safety, minimizing the carbon monoxide in the flue gases, minimizing the CO in the breathing air that we breathe, trying to get down to 0 parts per million in the ambient air. Also, obviously, it's combustion efficiency. Fuel, it's all about fuel savings, especially when you get into commercial and industrial boilers, where you're burning, the fuel costs are much higher than maybe a residential furnace or so, where combustion efficiency is important. And then the last thing is environmental, the NOx measurements, measure, measuring for, excuse me, clean air, looking at NOx and SO2 measurements. The 300 here, just a diagram here, illustration of a boiler where we're bringing in a hydrocarbon fuel, and we're bringing in air, which we all know is 21% oxygen and a balance of nitrogen. And what we're looking at are, obviously, we're pulling a sample from the stack gases into the analyzer, and we're looking at the O2 measurement, the oxygen measurement in the stack gases. We're looking at the temperature measurement, both the stack temperature through a thermocouple and also the primary air temperature. Oops, sorry, primary air temperature. We're looking at carbon monoxide. As we all know, carbon monoxide, CO, is a toxic gas. It can be produced primarily with all fuels, and we got to monitor that carbon monoxide coming out of the flue gases. And then the other measurements that we do are NOx and also pressure, which would be draft. Just want to touch a little bit on NOx there. You see that NOx, and then you see in parentheses NO and NO2. NO is nitric oxide. NO2 is nitrogen dioxide. The combination of both NO and NO2 equals the NOx. That's where you get the NO, and then you get the subscript X. Primarily on boilers and furnaces, 95% of the total NOx is coming from what we call the NO sensor. The other balance, which would be 5% or less, is coming from NO2. In the 300, for instance, we measure NO, which is 95% of the total NOx. And we factor in, and you can adjust this, preset this factor to anywhere you want, from 3%, 5%, 7% on the NO2. So we're measuring NO and we're factoring in the NO2. And again, remember that NO2 is a small percentage, 5% or less, of the total NOx. When we talk about total NOx, and if anyone on this presentation is doing EPA evaluations, compliance level testing, it may require you to have both sensors, NO and NO2. And when you have two sensors like NO and NO2 for total NOx, this is going to move you up a level on a combustion analyzer, and it gets you into a model what we call our Testo 350. So we do have you covered as well if you're doing total NOx. If you're doing just boiler testing and NOx, and you just want to get a better than a good ballpark reading, the 300 certainly is the instrument of choice when we're looking at NOx, and again measuring NO and factoring in the NO2. Just wanted to bring that to everybody's attention. 300, we're measuring stack temperature, we're measuring primary air temperature, percent oxygen, ppm carbon monoxide, ppm NO, and then the stack draft is measured in positive or negative H2O water column, inches of water column. And we're also calculating combustion efficiency. We're calculating carbon dioxide. Certainly the difference between carbon dioxide and carbon monoxide, everyone should know. Carbon dioxide is a byproduct of combustion. We're going to have carbon dioxide in our flue gases, whereas carbon monoxide or CO, we want to minimize that in the flue gases. Excess air is calculated, like I indicated to you in the previous slide, NOx, we're measuring NO and we're factoring in the NO2. And we're also correcting for NOx and CO at certain levels of oxygen. So in a combustion analyzer and in a Model 300, I bring this to your attention because in a combustion analyzer, we're pulling a sample of flue gases from a tip of the probe to a probe tube that's about 13 inches long through a hose assembly that's 7 to 8 feet long. And then it goes into the analyzer where the flue gases are filtered, where the flue gas, the water is taking out of the flue gases. And the last place that the flue gas goes is into the oxygen, carbon monoxide, and the NO sensors before it's exhausted out of the analyzer. So when we're doing a flue gas test, it's good to check your probe and hose assembly. Not only is the probe location in the stack important, but also if we make sure we don't have any leaks in our hose assembly. We do have a feature on the 300 that is called a gas path check, and I'll review that with you when we go over the operation of the 300. So if you look at the 300, and some of you may even have one next to you right now, but it's a very durable package. The heart of the instrument, the operation is an Android cell phone. So you have the same display. You have about a 5-inch display where you're going to look at your graphics, you're going to look at your measurements, and you can see everything on one display. On the bottom, you see from the bottom on the right side of this presentation, you'll see the hose connection. You'll see that if you look inside that hose connection there, above that arrow or below the arrow, you'll see there's a thermocouple connection there and two hoses. One's for the flue gas to bring in the flue gas. The other one is a separate hose for measuring pressure. And then all the way to the right here is the negative side of the pressure, the manometer actually that's internal to the instrument. This is this is where we're measuring the ambient air temperature, and we do have connections above that, 1 and 2, where we can add additional probes in case you want to look at primary air temperatures using a short probe to go into the primary air. So you do have optional probes. One is a carbon monoxide probe and a variety of different temperature probes. Very rugged instrument, very compact. And you can see here by this slide that we're operating the instrument similar to a cell phone. It is a cell phone. That's actually the display of the instrument. So it gives us the capability of zooming in, swiping, easily texting in input of customer names and contact information and measurement locations. You'll see through the presentation, you'll see a lot of graphics on this display, which makes the readings easier to see. Different ways of looking at the readings. The most important thing is that you're not scrolling through any screens. You can see all the readings that you want to see on one screen, and you can see as you're adjusting air and fuel, you can see what happens to the temperature, to the carbon monoxide reading, to the oxygen reading as you're trying to correct that air and fuel ratio so that you have very clean combustion, very safe combustion, and also very efficient combustion. Very protective lens cover, very strong housing bolted together. It has 4 magnets that hold very well on furnaces and boilers. And the sensors are digital sensors that can last up to 6 years. The 300 has the capability of 2 sensors, oxygen and carbon monoxide, and also has additional space for a third sensor, which would be the NO portion. Our standard measurements in the 300 are going to be pressure, temperature, both stack temperature and ambient air temperature or primary air temperature, oxygen, and carbon monoxide. And then we have a model that actually includes the NOx sensor or the NO sensor as well. You'll see through the operation of the instrument how quickly it is to go into measurement locations. One thing about the newer technology, and I think everyone understands too, that where documentation is getting more and more important, so that not only is it the customer information in there, but we also need to know the equipment, the information on the equipment that we're testing. And there's also measurement site location where you can put in the equipment size, you can put equipment type, call job numbers, things of that nature to store your readings. This instrument has the capability of storing thousands and thousands of tests through the use of over many years. Sensors, we have sensors that have a 2-year warranty. We have sensors that have 4-year warranties. One thing about electrochemical sensors, Testo has really expanded and improved over the years on the integrity of these sensors. They're lasting much longer than 2 years or so. So you're getting up to 6 years operating life out of an oxygen sensor and the carbon monoxide sensor. If you're familiar with the previous models, we're still using the same probe and hose assembly. So it's a modular probe and hose assembly with one hose coming up. Internal to that hose is what we went through: the pressure hose, flue gas hose, and the thermocouple. Easily connected to the bottom of the instrument. You're not going to break any K thermocouple wires. You can tie a knot in this hose assembly and not break anything. It's a very durable probe and hose assembly, and that's why we stuck with it with the newer 300 models. And then you certainly have probes here, ambient CO probes and other probes that we talked about for adding additional capabilities to the instrument. Sensor diagnostics tells you when sensors are bad, tells you when to replace a sensor, and it is all these sensors are fully replaceable in the field. Very simple operation to replace the sensors, and hopefully you don't have to do this that often. You shouldn't have to with Testo. Like I said, we're up to 4-year warranties with most of our sensors now. Again, memory storage capability. We also added on a 300 Wi-Fi connection. So now you have the capability of taking the readings inside a boiler room and sending them through Wi-Fi, either through a hotspot or a Wi-Fi connection. send them anywhere you want through the web. So you can instantly take these readings and send them to your supervisor, send them to the customer, whoever you need to show the documentation to. And every 300 has this capability. Every 300 has software that's offered with the analyzer. Again, I can't speak highly enough about Testo's probe and hose assembly. If you used a Testo probe and hose assembly before, I think you'll agree it's very rugged, very modular, very adaptable to different stacks, because you can take the probe tube off at the probe handle and replace it with a longer probe, a flexible probe, a high temperature probe. We get involved in a lot of different applications, and from anything from a residential boiler to a large utility boilers. Additional probes, water trap is at the base of the instrument, spill valve access. Obviously, when we're bringing in flue gases, they're hot, they're wet, they're dirty. So we have particulate trap at the handle, the back of the probe handle, and the water trap is at the base of the instrument, where you got to keep your eye on. There's water levels that if you exceed a water level, you want to be able to dump out the water from the analyzer itself. The on-off button, certainly, it's an on-off button, very quick. The warm-up time on a combustion analyzer with Testo is a 30-second warm-up. We also added a feature where you can go into a standby mode. So if you're in the same boiler room and you need to do 2 or 3 boilers, you don't have to keep shutting the instrument off and turning the instrument on. You can just go into a standby mode. So let me just get out of this program here right now, and bear with me as I change here from a PowerPoint presentation to a to what oops, there we go, to a power mirror. And what this allows me to do, if it works, yeah, it's working, is it allows me to show you the operation of a Testo 300 on the screen here. So I just want to go through a couple things on this. Yeah, this is where most of you want to attended this program to get a little bit better idea on the operation of the 300. This is an easy instrument to operate. The center button in below here is my on-off button for my internal pump. I just shut off my internal pump, and you'll see the display here saying here's Baptist Hospital here, boiler number 4. That's the location that I'm at. Here we have over here, if I push uh, the fuel button, the measurement type button, you'll see that I have a lot of different measurements that I can do with this analyzer. Some of these measurements will not pertain to maybe to your market. Others pertain more maybe to the European market. The 3 measurements you're going to be doing a lot is certainly the flue gas, the draft measurement. If I hit the draft measurement right now, I'm going to do a draft test, and I'm going to hit this button on the bottom here, which is going to turn that on, and it's going to tell me to take the probe out of the stack, press OK, because I'm zeroing the pressure sensor to the atmospheric pressure. And you can see right now it's 0, 0, 0. So what I could do is I can move this probe back and forth, and I'm creating some pressure. Now I can also look at this on a graphic form as well. You can see how that measurement's jumping up and down as I move the probe. Can hold the display, and when you hold the display, I can take this and print this information or move it to store the readings. The other measurement that you're going to be using quite a bit, I believe, or you could, is that there's a reading called CO ambient. And if you're doing any type of residential, commercial boiler tuning, you can also measure ambient air. And I just put it into the ambient air mode. I'm going to press the pump I'm bringing in a sample right now, and this is where I do a sample of carbon monoxide in the breathing air. If you're using this in a residential application, you could be in a home right now, checking where the living area is. If you're in a boiler room, you're checking in a mechanical room where uh, personnel are, the maintenance people are, and you're checking carbon monoxide in that area as well. Just like the just like the other draft reading, we can graph this reading. And as I put some heat to this probe, you're going to see that the O2 is going to, the CO is going to jump up a little bit. Well, maybe not quite that fast, but there it goes. So you can see how it's pulling in a sample of CO, very little CO that I'm creating, but you can see the representation of the graph here as it's climbing and going back and forth. Now there is alarms in here as well, so I can set alarms at wherever you like, 10 ppm for ambient air, 20 ppm for ambient air. Stop the pump, go back to my flue gas analysis. This is the screen that you're going to be on the most. This is a screen that allows you to look at many parameters simultaneously. You're in the flue gases, and on the bottom here, you'll see a gear, a service gear. This is my pump, on and off pump. And this is where, if I press that button here, I have the capability of sending my data to through Wi-Fi. I can print to an IR or to a Bluetooth printer. These instruments come with or without Bluetooth printers, and you can save the readings, as I said, internal to the instrument. Now, if I hit the top button right here, or looking at Baptist Hospital, it's a hospital near where I live. I'm in North Carolina, and I go into the customer measurement site locations. This is where I add customer information, or I can change something on the screen. Like instead of going to Baptist Hospital, let's say I'm going to Greensboro school district here. We're going to look at some boilers, and I already looked at two boilers here. Burner number 2, let's call it. And this is the information on boiler number 2 that I inputted previously when I was there at the hospital, or I'm sorry, at the school district. So now you'll see that I just changed my heading to Greensboro Schools, boiler number 2. And what I can do now is when I'm taking a test and I start the pump and I start getting my readings of flue gases, and you see what I'm doing is I'm driving down the oxygen reading a little bit. I'm gonna stop the pump. This is not your typical reading in a boiler, but I'm simulating this here in my office. But you got the percent of oxygen on top. You got their stack temperature. Percent oxygen should be anywhere between 4 and 6 or 7% oxygen, depending on what type of combustion process you're on. Stack temperatures could be in the 400 degree temperatures. You want a trace of carbon monoxide. There's your ppm CO, your calculated combustion efficiency. If you have an NO sensor, that would be your NOx reading, carbon dioxide reading, pump reading. You can also look at this on a graph. So as I turn the instrument back on, you'll see that the lines are changing based on everything's coming back up to ambient air conditions. Go back to the list here, and you'll see you can look at these readings on a graphic display, or you can look at them from a number standpoint. You'll also see what we have up here is called hotspot. And what the hotspot is, and they use this a lot in Europe, they take a combustion efficiency test at the highest stack temperature in the stack where they're sampling. So what they do is they turn the instrument on and they put the probe in the stack, and it's going to show them where the hottest stack temperature is. And wherever the hottest stack temperature is in the stack, that's where they're going to take their reading. I just breathed into the probe to bring the temperature up a little bit, let's say, and now that, it would read around 350 degrees or so, but you would get an idea of where to put your probe in the stack where it's the highest stack temperature. We don't use it as much here in the United States, but it is a good indication where to take a efficiency test when you're looking at the highest stack temperature in the stack. The gear on the bottom, when I go down here, for instance, if I press that, what I can do with the analyzer is I can configure this measurement display that you see here. Here is the display that I'm looking at. And if I wanted to see oxygen as number one, I could press on oxygen and move it up and move it above stack temperature. So what I do when I'm taking a test is I'm looking at 1, 2, 3, 4 are my major measurements or calculations that I want to look at. So in this case, I got oxygen, stack temperature, CO, NOx, and then I look at combustion efficiency. Let's say you don't want to look at CO2, you can just take CO2 out. Let's say you want to add something um, that's not on the display. Well, here's all your options that you can add to your display. So if you want to look at delta T, you want to look at CO ambient, you want to look at NO, I can add that to my display, and I could just confirm that, and then now you can see that I've changed the display in a way that meets my testing requirements. Some of you may have reports or so that list certain measurements and calculations that you need, and you can mimic those reports by changing the order of the display. Whatever this order is on the display is the way it's going to print. It's the way it's going to store the readings. Everything is set up and printed and copied and pasted in memory based on the order sequence that you see on this display. And you can see how easy it is to change the display. They're factory set, but you have the capability of setting it up to your needs, and you may have different needs than what we think they are. Um, Up on top of the display, you'll see it has Bluetooth, your Wi-Fi. This is my battery capacity here, the time. That's my battery capacity right there. Right here is a menu button. And you may be looking at this menu quite a bit. Here is the customer, like I said, customer site location. Is again what I showed you previously. That you get off of the main display. Here are the tests that are stored in the instrument. So I could go into, let's say, Jones Residence, and I have a residential oil burner there, and I can pull that up and I can show the previous tests that I did over a period of time. You'll see here that on 1020, I had a test that I did on a residential furnace, and there are my readings right there. So you can keep thousands of tests stored on this analyzer. Um, but like I said, you're going to have a list of all these customer names on here, and then after the customer name, you can go in. There's going to be what we call the saved measurements are at the site location under the Baptist Hospital under the customer's name. So if I go to boiler number 4, because Baptist Hospital has 4 boilers, now I'm going to show the previous tests that I did at the time and date of these tests on those boilers. So some of these tests go back quite a bit, almost a year or so, because I was there. It's been a while since I've been there. So then you can also sign the report, things of that nature. I can delete it. But here's something that what they look like as far as a PDF here. I'll show you a PDF here in a second. So let's see, get back here. So if I go into test, Oops, wrong one here. Saved reports. Now you go into saved reports. I pull up a current test. This is what a PDF file looks like. And you can input a lot more information. You'll input photos um, into it, lot of customer information, comment section. But if you look at the report, this is a report that was done, measurement, the measurements, what were the measurements, and very detailed. You can have a very detailed PDF report showing all the information. So one of the things that I wanted to show you was gas path. This is a pretty important test, I think. Um, you should do this like once a month on a combustion analyzer. What we're actually doing with this is we're looking at the path of the gases through the probe and hose assembly. And with your analyzer, you get a rubber cap that goes on the tip of your probe. And what I can do here is it's telling me my liters per minute. And if I put that rubber cap on the probe tube of my probe and hose assembly, I'm going to create a vacuum in my instrument. And that vacuum needs to go down to zero, almost zero, before it passes the test. Right now, it's telling me it's tight, which means that my water trap is closed. I have no leaks in the hoses. Um, my filter and my top of my probe handles locked in place, so I can do a test and not have to worry about any type of dilution from outside air or so. It's a very nice test that you have access to in the analyzer. And like I said, it's right under the main menu, path gas path check, device settings. Um, just gives you your device settings, what you can do um, to the display itself, add Bluetooth, to delete the Bluetooth, email information. One thing that's important that I always recommend customers to do is look at the sensor protection, carbon monoxide. If I click on that, I can protect the CO cell. The instrument CO sensor goes up to 4,000 parts per million. I can change that so that the instrument shuts itself off after 1,000, 2,000, whatever number I put in there. I could shut it off at 500 ppm if I want to, and press this OK. Now it's telling me that my instrument is going to shut off at 500 ppm when it sees over 500 ppm. The reason why I'm showing you this is because the CO sensors are very accurate sensors down to 5, 10, 3 parts per million. And if you're tuning a boiler and you put it into that fuel-rich mixture and you start getting a high concentration of CO and you go over the 4,000 ppm, you could actually damage the sensor and throw it out of calibration. In flue gases, as you know, we should see less than 100 ppm CO. And even though the sensor goes up to 4,000 ppm, we want to shut that instrument off way before it gets over that 4,000 ppm. And usually I set it at 2,000 or so. The other you could do it with the NO sensor as well. And then when we talked about NO2 adder, if you do have an NO sensor and you want to add an extra 5% to get the NOx, you can do that by just putting in 5%, 3%. It's factory set, I believe, at 5%. So alarm limits. These are the alarm limits that I set up when I was doing that CO ambient test. You can have not only a visual alarm, but also an audible alarm that shows you that alarms when you exceed a certain ppm of CO when you're doing primarily an ambient CO test. So let's go back to the screen here. I think we covered mostly everything. Let's just take a test here. I'm going to run the pump. I'm gonna stay at the same location and if I go to the If I shut my pump off now, and you see the arrow here on the right bottom, I take my readings. I got three things I could do. I could send the data. I can print the data to my Bluetooth printer. If you have one that comes with a Bluetooth printer, and sometimes you can get kits with printers and without printers, or let's just do a save test. If I save it, you just see how quickly it saved the test under Baptist Hospital boiler number 4. If I go back there and I say, let's send the data, I want to send the data, email it. I could put in my company address, John J. Feigen at Testo, and the information is, you'll see the attachment already attached, and I can just send it email. I just sent that data to my email at jfeigen@testo.com. Very simple to navigate through the instrument. This is very easy to use. Error list. You got it tells you when you have errors. Sensor diagnostics tells you what your sensors are okay. This instrument has 3 sensors, O2, CO, and NO, and they're all okay. And during the power up, if you have a sensor failure, the instrument's going to tell you you have a sensor failure during that 30-second power up. Okay, so that was a quick review of the operation. Hope you stood with me on that. Let me just close this out. Go back to the PowerPoint presentation. Got a few more slides here that I'll cover, and then we can open it. Whoops. Then we can open it up to questions. Hold on for a second here. I messed that up. Current slide. Okay. So let me just continue on a couple more slides. As you see here, this is whoops, sensitive keyboard I have, but you'll see the orange dots. That's what we went through. The flame is your fuel test, all your different tests that you do. I didn't show you how to change fuels, but you'll see there the natural gas in the center there with an arrow down. I just hit that arrow key and I got another 8 to 10 different fuels that I can select a fuel oil 2, fuel oil 6, propane, wood, all kinds of different type of fuels. And it's important that you select the right fuel so it calculates the combustion efficiency correctly. We went through the list, the graphics, the hotspot, the bottom 3 buttons. The center one is the on off for the pump. The up arrow key is for you to print, save, and email location to email to your customers and users and your supervisor. Again, we talked a little bit about this already. I'm not going to dwell on it, but these sensors are replaceable in the field. So if you're looking at a combustion analyzer, there's 3 or 4 questions you need to ask yourself. Number 1 is, what is your combustion process? You're doing strictly residential. If you're doing strictly residential and oil burners, residential light applications, you may not need a 300. We do have a 310, which covers just the residential market. The 300 is designed more for if you're doing residential, commercial together, commercial, industrial. This is where you get into a 300. Does your combustion process require you to measure NOx? Not only does it require you to measure NOx now, but maybe next year you're going to be measuring NOx. If that's the case, then you need to get a 300 that has NOx capability, and I'll show you that in a second. Do you want to save, email, and print your readings? All the 300s save, email, and print readings. Now, with the printing side, you need the printer, of course, but it has the capability. All 300s have the capability of printing to a Testo Bluetooth printer. And then are you interested in extending the CO sensor range? We have a model that I'll go through that goes up to 30,000 ppm on the CO. In case you want to look at carbon monoxide and you want to look at oxygen and you're adjusting your clean air ratio, you're adjusting your air ratio, and you're trying to minimize the oxygen down to a point where you start building up high concentrations of carbon monoxide, we have an analyzer that's capable of doing that. This is a product selection guide that's actually on our internet site. So let's say if you're measuring oxygen and CO, and you don't want to measure NOx, these are the two models you're looking at. It's called a smoke addition. It has capability of measuring O2, measuring carbon monoxide, measuring pressure, measuring stack temperature and ambient temperature, and calculating all the combustion parameters. It comes with software, comes with a soft case. The top model doesn't have a printer. The bottom model does have a printer, and you'll see some suggested list prices attached as well. If you get into if you want to measure NOx, then you get into what we call our Pro Series or an Industrial Series. And you'll see that it has the capability of measuring oxygen and CO up to 4,000 ppm, and it can be retrofitted with an NO sensor. It doesn't come with one at the time of shipment, but it can be upgraded at a later date. The far right one here comes with the NO sensor included, which means that you really have three sensors, O2, CO, and NO. And this higher end model here at 3565 also has a sensor and a dilution, an extra pump inside the instrument that can exceed, that allows us to measure up to 30,000 parts per million in CO. Again, for those industrial guys, high-end commercial guys that are tuning boilers for maximum combustion efficiency. So there's the lineup of the 300 combustion analyzer. Residential, which I indicated to you, is a 310, a lighter duty type instrument. Doesn't have the capability of Wi-Fi or storage, but is very good for residential oil and gas burners. Then you get into the smoke addition, which is a very common instrument because a lot of contractors, maybe like some of you may do residential, both residential and commercial. And then you have the higher end instrument that's for commercial and industrial applications that allows us to do the NOx measurement. Okay. Tips on a 300: sample continuously in a mechanical room and into the stacked gases. You have the capability of conducting other tests. You can do delta T, delta P, carbon monoxide ambient. I showed you the draft and the CO ambient measurements that we do. You can check carbon monoxide everywhere around the combustion appliances. Good thing to do. You can look at steady state combustion. That means that when you're doing a combustion test, typically you want the boiler to warm up to a certain point where it has its highest stack temperatures, everything's being mixed properly, and then you would do your combustion efficiency test. Placing sample probe in the proper location is important in the stack, knowing the relationships of combustion gases, and then taking those readings before and after, and having either storing the readings or printing the readings or both by time and date of the test. Tips on maintaining a CO analyzer: check your battery status prior to testing. These uses the 300 use lithium ion batteries. Charging time is about five hours, and then the decharge time, depending on how often you run the pump or so, could be up to 8 to 10 hours of discharge. So you're getting a full day's work out of the instrument. You can't overcharge the batteries. You can charge them overnight. They're protected. You really can't over damage the batteries by overcharging them. Don't overrange your CO sensor. I showed you a little bit of how to put determine a level of CO that's below the range of the CO sensor and setting that range to 1,000 to 2,000 ppm CO. Maintain recommended calibration intervals and just remember that every time you turn on an instrument, a Testo 300, you're calibrating the oxygen sensor to the ambient fresh air in the room. So every time you turn the instrument on, you're actually calibrating the oxygen sensor for ambient air, which is 21% oxygen. Don't put the probe in the stack when you're sampling, when you turn the instrument on, unless you're using that high-end 300 that I talked about that goes up to 30,000 ppm, because that has an extra pump in, which actually brings the sample air from the side of the instrument. Calibration of your electrochemical CO and NO sensors periodically requirement. Testo recommends once a year. Send the instrument back to us. We keep track and can calibrate these and put a sticker on to make sure you understand that they've been calibrated with a certificate. You may have your own calibration protocol, so you may want to do this more frequently than what we recommend. That's up to you. Check water traps and filters before sampling. At the probe handle, there is a filter at the probe handle, and that can be easily changed out when they get dirty. And they're white filters, and when they turn black, it's simple as that. You just unscrew the cap and turn the cap to counterclockwise and take out the filter, put in a new filter, you're ready to go. Storage limits, be careful, especially in the northern Canada, things that keeping these inside a vehicle overnight. The big thing is the condensation. So you go from a very cold environment to a warm boiler room. You could create some condensation internally to the instrument, so be careful with that. And certainly if you forget to dump out the water in a water trap and you keep it overnight and it freezes, ice expands, could crack the water trap. And then, as I indicated, conduct leak checks periodically. And as you'll see with Testo, cost of ownership is very, very low. Calibration, but sensors today do not need to be replaced every year. If you replacing sensors every year, whether it's an O2 or a carbon monoxide sensor, it's something you're doing with the instrument, or it's probably not a Testo instrument. Taking care of these sensors can last 4 to 6 years before you replace the sensors. We went through this again. It's a very solid instrument. 30-second warm-up time, very fast velocity hoses, pre-calibrated field replaceable sensors. We have a lot of expertise at Testo. Our inside salespeople, our marketing people, and certainly our regional managers, such as myself, can help you in a lot of different ways in understanding the operation of combustion analyzers. The last thing I have is Testo is having a promotion this year. We do this periodically in the fall season, and if you buy a Model 300, any of the models, they have to be 300s. We're providing a MP3 Vito bag. It's a very nice, it's over $100 Vito bag. It's actually a soft case for the 300, even though the 300 comes in its own case, but you'll have two cases, but it's a very nice bag. And when you buy a 300, purchase a 300 from our distributors, you can go to our internet site, fill out the redemption form, and we will ship you directly your MP3 bag. And with that, I'm going to pass it over to you, Jolie, if you're still there.
I am still here. Thank you so much,
Okay,
John. That
thank
was a
you.
really thorough and great overview. So thank you so much. And we have some time for some audience Q&A. So if anyone does have a question, please submit that in the panel on GoToWebinar now. We have already received a couple. So the first one I have here is, My 300 shows a wheel spinning when I press the on button, but the pump does not turn on. What does that mean?
Yeah, that's a good question. What that means is that there's two battery packs in the 300. One is in the cell phone device itself, which operates a display, and the other is a larger battery pack that's in the main body of the instrument, which runs the pump and the sensors and the printed circuit board internal to the instrument. When you get a spinning wheel like that, and the pump is not engaging and it doesn't start sampling, going through the warm-up cycle of 30 seconds, that's an indication that your batteries are low, and that you need to charge your batteries. And that again, that you can do this overnight. You can do a quick charge and get you through the job. But usually when the spinning wheel is spinning there, it's not engaging the power supply that's operating the pump and the batteries, because that's too low and it needs to be charged. Those batteries need to be charged.
All right, great. Thank you, John. And then we have a couple of questions related to sensor shelf life and replacement. So, do the sensors have a shelf life, and are they very difficult to replace?
The instrument, first on the difficulty of replacing, they're very easy to replace. You're using a hex screwdriver. Um, let's see, what do they call that? It's a star type screwdriver. They're very common. Everybody probably has one. You're just taking out 4 screws and splitting the instrument apart, and then you have access to the sensors. And like I said, you shouldn't be doing this that frequently, but after 4 or 6 years, yes, you will be replacing sensors in the instrument. As far as shelf life, the carbon monoxide sensor and the NO sensor is dependent on uh, concentration of carbon monoxide over a period of time and the use of the instrument. The oxygen sensor. Over the oxygen sensor is similar to a battery. It's always putting out an output, even though you're not using the instrument, say over the summer months. That oxygen sensor is still generating an output, and the sensor life on an oxygen cell, as indicated, has a four-year sensor warranty. It may be a little bit less than the toxic gas sensors because it's always operating, but it's under warranty for 4 years, and the new O2 sensors have been lasting for 6+ years. Big thing with carbon monoxide sensors, guys, is you don't overrange that CO cell, because then if you overrange a cell and you're seeing 10,000, 6,000, 8,000 ppm, and you overrange that CO cell, you may need to replace that CO cell prematurely because it has been overranged. And that's why we provide some added protection by shutting off the pump at a certain predetermined level. Um, but no, it's easy to replace the sensors, and the shelf life has dramatically increased over the years.
Great. Thank you so much, John. And we are almost out of time today. I think we'll have time for one more question, if that works. This last one we'll take here says, what's the main difference between the Smoke Edition and the regular Orange 300 series?
That's a good question. The if you purchased a 300 last year, and it has the same part number as the Smoke Edition, the only difference is in the color of the case. Marketing decided, and our team of product managers decided to change the color of the mid-range 300 so we could differentiate it a little bit better. Um, we have two models. The black Smoke Edition model is the commercial model, and the orange model now is called the Industrial Pro Series. If you look at it today, The black model, the black instrument does not measure NO. It will never measure NO. The orange model 300 will measure NO at either immediately if you get the sensor in there or at a later date when you add a new sensor to it, add an NO sensor to it. I hope that explains the reason why we changed the definition of the product a little bit.
All right, great. Thank you so much, John. And we are actually just about out of time for today. So we'll have John respond to the rest of the questions that we have received via email. On behalf of Testo, I want to thank everybody that attended our session today, and thanks to John as well for a great session on understanding and operating the Testo 300 Combustion Analyzer. Thanks, everybody. Have a great rest of your day.
Thanks, guys. Thanks, everybody. Take care. Bye-bye.